Welcome to AmeenAcademy.com. In mini tour of physics, let us discuss about various branches and its explanation of the physics. Physics is the scientific study of physical phenomena like the motion of matter and energy and force. It helps us to understand the world around us. Physics is the most fundamental part of science. Newton, Galileo and Einstein have all been called the fathers of modern physics. Newton was called this because of his famous law of motion and gravitation, Galileo for his role in the scientific revolution and his contribution on observational astronomy, and Einstein for his groundbreaking theory of relativity. What are the main branches of physics? Physics is constituted of many interdisciplinary subjects and branches for those interested in making a career in this field. Here are all branches of physics: classical physics, modern physics, nuclear physics, atomic physics, geophysics, biophysics, mechanics, acoustics, optics and thermodynamics, and astrophysics. Among the popular branch of physics is classical physics. It is primarily deals with effect of different law of motion and gravitations. These theories are conceptualized by Sir Isaac Newton and James Clerk. They are Maxwell's kinetic theory and the theory of thermodynamics. This branch of physics is concerned with matter and energy. Classical physics can simply be termed as physics, which dates back to 1900 and before. Everything that comes under the discipline of physics after that era, that is after 1900, is considered to be modern physics. In classical physics, energy and matter are dealt with separately. As a general belief, the theories which are termed invalid in modern physics are immediately considered to be a part of classical physics. Modern physics primarily centered around the two theories of relativity and quantum mechanics. Albert Einstein and Max Planck are the pioneers of this branch of physics. They are the first to propound the theory of relativity and quantum mechanics. Unlike the classical branch of physics, the branch of modern physics does not consider energy and matter as different entities. Here they are only called the two different forms of each other. Nuclear physics. This is a branch of physics that is concerned with the constituent structure, behavior and interaction of atomic nuclei. This branch of physics is different from that of atomic physics. Later studies the atom, including its electrons. In contemporary times, nuclear physics has become a very broad area of study and extended its scope manifolds. Methodological and principles of this subject are applied to other academic and research areas. It is used in power generation, nuclear weapons, magnetic resonance, resonance imaging, medicines, and industrial and agricultural isotopes. Atomic physics. Another branch of physics is atomic physics. It is concerned with the composition of the atom apart from the nucleus. It is primarily concerned with studying and understanding the behavior of electrons in the shells around the nucleus. This branch of physics deals with electrons, ions, and neutral atoms. Among the first and foremost forays into atomic physics was a recognition that all matter is comprised of atoms. The beginning of atomic physics is associated with the discovery of spectral lines. This discovery gave way to an entirely new understanding of the structure of atoms and their arrangements. Mechanical physics. This is one of the branch of physics that is concerned with understanding the motion of material objects and how they are influenced by forces. It is also simply called mechanics. It has two main branches of classical mechanics and quantum mechanics. Classical mechanics studies the law of motion of physical objects. It also deals with the forces that cause the motion. On the other hand, quantum mechanics is the branch of physics that is primarily concerned with the behavior of the smallest particles like electrons. Quantum mechanics is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. It is the foundation of all quantum physics, including quantum chemistry, quantum field theory, quantum technology, and quantum information science. Mechanics. Mechanics is the branch of physics that focuses on the movement and motion of physical objects under a force and when it is rest. It studies the relationship between the different concepts like force, matter, and motion. Forces applied to objects results in displacements or changes in an object's position relative to its environment. It studies the law of motion, gravitation, friction, displacement, and concepts like force, energy, and power. Acoustics is a branch of physics that studies sound. It studies the mechanical waves passing through the different forms like gases, liquids, and solids. It studies vibration and focuses on the production, control, transmission, reception, and effects of sounds. It studies concepts like vibration, sound, ultrasound, and infrasound. Optics is a significant science branch of physics that studies light and its properties. Optics focuses on studying behavior properties of light, its interaction with matter, and the changes in these behaviors and interactions. The branch of studies the behavior of visible, ultraviolet, and infrared light. There are 12 branches within the field. Physical and geometrical optics. Physical is concerned with the nature of light and other attributes, while geometrical focuses on light interaction with lenses, mirrors, and other devices. Thermodynamics. Thermodynamics is a branch of physics concerned with the heat and other forms of energy. It focuses on the transfer of energy from one form to another. It was introduced in 19th century while scientists worked on steam engines. There are 3 laws of thermodynamics that are the foundation of the branch. Aerophysics. Aerophysics is an important branch of physics. Space science is a subset of astronomy that primarily studies celestial objects and their composition by applying the laws and principles of physics to explain the phenomenon. The study of astronomy and its branches can be dated back to Greek philosophers like Aristotle, who sought to study space and its components, but it was Galileo and Newton that transformed the tradition of astronomy and its study. The study of cosmology and planetary science is closely associated with astrophysics and is often referred to as sister science. Geophysics is a subject of natural science concerned with the physical process and physical properties of the earth and its surrounding space environment. Further detail, geophysics deals with a wide array of geological phenomena, including the temperature distribution of the Earth's interior, the source configuration and variation of the geomagnetic field, and the large-scale feature of the terrestrial crust such as rifts, continental sutures, and mid-oceanic ridges. Modern geophysical research extends to phenomena of the outer parts of the Earth's atmosphere. Example, the ionospheric dynamo, auroral electrojets, and magnetopause current system, and even to the physical properties of the other planets and their satellites. Many of the problems of geophysics are analogous to those of astronomy because the subjects studied is rarely under direct observations, and conclusions must be drawn largely on the basis of mathematical interpretation of physical measurements. This includes measurements of the Earth's gravitational field with gravimeters on land and sea and artificial satellites in space, magnetometric measurements of the planet's magnetic field, and seismological survey of surface geologic structure using the reflected and refracted elastic waves produced by earthquakes or by artificial means. Research conducted with geophysical techniques has proved extremely useful in providing evidence in support of the theory of plate tectonics. Seismographic data, for instance, have demonstrated that the world's earthquake belts mark the boundaries of the enormous rigid plates that constitute the Earth's outer shell, while the findings of paleomagnetic studies have made it possible to trace the drift of the continent over geologic time. Next, biophysics. Biophysics is the branch of knowledge that applies the principles of physics and chemistry and the method of mathematical analysis and computer modeling to biological systems, with the ultimate goal of understanding at a fundamental level of structure, dynamics, interactions, and ultimately the function of biological system. Biophysics seeks to explain biological function in terms of the physical properties of specific molecules. The size of these molecules varies from the very small fatty acid and sugars, that is from 1 nanometer to 9 to 10 meter, to macromolecules like proteins 5 to 10 nanometer. Physical scientists use mathematics to elucidate what happens in nature. Life scientists want to know how biological systems work. This system includes molecules, cells, organisms, and ecosystems that are very complex. Biological research within the 21st century involves experiments that produce huge amount of knowledge. How can biologists even begin to know this data or predict how the system might work? This is where biophysicists come in. Biophysicists are uniquely trained within the quantitative science of physics, math, and chemistry, which they are able to tackle an honest array of topics, ranging from how nerve cells communicate to how plant cells capture light and transform it into energy, to how changes within the DNA of healthy cells can trigger their transformation into cancer cells, to so many other biological problems. So far we have discussed about physics and its subdivisions. If you have done, please subscribe our YouTube channel.